In this video lesson, we're going to be looking at parallel and perpendicular lines. So we're going to need to be able to write an equation of a line that contains a given point and is parallel to a given line. So this is just like writing an equation where you're given a point and a slope. But our slope is going to come from our understanding of a parallel line to another given line. Here we're going to write an equation of a line that contains a given point and is perpendicular to a given line. So again, you're given a point and a slope, but you determine your slope based on what one line being perpendicular to another means. And that's what we're going to be learning very specifically in this lesson, is the idea of parallel and perpendicular lines. All right, so here is just examples of parallel lines. So parallel lines have the exact same slope. You can see here that they will never intersect. They will always stay a specific width apart, or they will never intersect. Perpendicular lines actually do intersect, and they intersect very specifically where they create a 90-degree angle. All right, so again, parallel slopes and perpendicular slopes. Now, as I've kind of already said, if lines are parallel, then they have the exact same slope. So in the equation, your m of y equals mx plus b, or your slope, is exactly the same. This purple line has a slope of 3/5, a rise of 3 and a run of 5, and so does this green line. Rise of 3 and run of 5. They're just going to have different y-intercepts. So same slope, different intercepts. All right. Now, when lines are perpendicular, okay, their slopes are what we call negative reciprocals, or we could say opposite reciprocal. So if this purple line is positive, as we move from left to right, it's moving up. So that's a positive slope of 7/6. It's a rise of 7 and a run of 6. Well, the green line, which is its perpendicular line, has a negative slope. So it's opposite, or we could say the negative of positive is negative. Okay, so the opposite of positive is negative. So the green line has a negative slope, but it's not the same rise over run. It's the reciprocal. So you'll notice the purple line had a slope of positive 7/6. So the green line has a slope of negative 6/7. Okay. So again, if they're going to be perpendicular, one slope is positive, one is negative, and the fractions are the reciprocals. All right, let's apply this in a couple of examples. Example 1 says, what is an equation of a line that passes through the point -1, 2 and is parallel to the line 3x plus y equals 3? Okay, first thing we can identify here is that we have a point, okay? So we have a point, we need a slope. Now, we are given an equation, but notice this equation is in standard form, okay? Now, I've also taught you how to find the slope in standard form by using negative b over a, but one thing we also need to be sure we're comfortable with is taking this standard form equation, 3x plus y equals 3, and converting it to slope-intercept. So remember, we're trying to solve for y equals. Well, if we want to get y all by itself here, we have to remove the 3x. Okay, so we talk about removing the 3x by using the reciprocal. I'm sorry, not using the reciprocal, but using the inverse operation. So the inverse of a plus 3x is to subtract 3x to get rid of it on the left side. So that means we have to subtract 3x on the right side. Now, there's no x to subtract it from, so that just means we have a negative 3x. And then, of course, we had our plus 3 that we just bring down here. So we would write plus 3. So from here, you should understand that the slope equals negative 3. So now we have our point and our slope. All right, so we're going to write an equation. So our equation is going to be in the y equals mx plus b form, because when it just says equation, that's what it means. It doesn't say write it in point slope equation. But we know that our m is going to be a negative 3x. So our equation is definitely going to read y equals negative 3x, but we have to determine what the b is. Well, that's when we use our given x and y and plug it into the equation and figure out what b is, and then we can write the final equation. So when we plug in our given x and y, our y is 2 when our x is negative 1. So we're going to add, so we're multiplying the negative 3 times negative 1 and then plus b. So we're going to just keep working this equation out. So that means 2 equals positive 3 plus b. And then if we're going to solve for b, we're going to subtract 3 from both sides. And now we know that b is equal to negative 1. Well, if we know b equals negative 1, we can simply just take this answer and plug it in here. And our final answer will be y equals negative 3x minus 1. And that is an equation that passes through the point negative 1, 2, and is parallel or has the exact same slope as this line here. Now, if you wanted to confirm that you were correct, you could always plug this equation into Desmos.com to see it graphed, and then you could plug this equation into Desmos.com as well, and you will see that both of them are graphed. They have a parallel slope, and this one crosses through the point negative 1, 2. All right, let's take a look at example 2. This says, what is an equation of the line that passes through the point negative 4, negative 6, and is perpendicular to the line 2x minus y equals 6? So again, we are given a point of the line and we're given the slope, but all we know is that it has to be perpendicular to this line. So let's go ahead and take this line and put it into slope-intercept form so that we can determine what the slope is and then find the perpendicular slope, okay? So our slope in standard form is 2x minus y equals 6. We want to solve for just y equals, or positive y. So I'm going to get rid of this 2x. You could say that you just want to move it over here and it becomes negative 2x. Or we subtract it from this side to get rid of it. So we have to subtract 2x from over here to keep it equal. Now our equation says negative y equals negative 2x plus 6. Well, we're not looking for negative y equals. We want positive y equals. Well, this is like saying negative 1y. That's what it is. It's a negative 1y. If you want to make that a positive, then you have to divide by a negative 1. You're dividing all of this by a negative 1, though, to keep it equal. And really, all that happens is this negative y divided by negative 1 just becomes positive y. You're just really switching the signs. So y equals, same thing here, negative 2 divided by negative 1 makes it a positive 2. So that becomes 2x. And then the positive 6 divided by a negative 1 makes it a negative 6. So then this is our equation, y equals 2x minus 6. And we need a line with a slope that is perpendicular to y equals 2x minus 6. So if the slope is 2, which is the same as 2 over 1, then the perpendicular slope would be 1 over 2, and then it's the opposite. So remember, perpendicular slopes are the opposite or the negative reciprocal. So the fraction 2 over 1, the reciprocal is 1 over 2, and it was positive, so it becomes a negative. So now we're using a slope of negative 1/2 in our new line. So our equation is going to be y equals negative 1/2 x plus b. And now what we have to do is to determine what is the b by plugging in the x and y here. That'll give us the b, and then we can just rewrite this equation with the b that we determined. So we have our x and we have our y. All right, let's go ahead and plug that in. That means y is equal to negative 6 when x is equal to negative 4, and then plus b. All right. Well, if we work this out, this says negative 6 equals, and then 1/2 of negative 4, or 1/2 times negative 4, is negative 2 plus b. And then we're going to add 2 to both sides. And then negative 6 plus 2 is negative 4. So negative 4 equals b. Now that we know that b equals negative 4, we just plug it into here. And our final equation is going to be y equals negative 1/2 x minus 4. That is your final answer, and that is going to be the end of part 1 of the video of parallel and perpendicular lines.